Good morning, guys. I hope you guys had a nice weekend. I hope you did not have any stress working on that test. I tried to make it as straightforward just to make sure that you guys know the appropriate formulas. Well, today starts the fourth marking period. It's horrible that this is how we're starting the last marking period of the year. We are going to go back to a chapter that we had skipped. So we're leaving trig, I'm sorry to say. I know that makes a lot of you sad and makes a few of you happy, but we're going to go back into something that you guys already learned before, logarithmic functions. You learned that in Algebra 2. Oh, I hear the collective groans out there. Okay, so since this is remote learning, we are going to go into logarithmic functions a little differently. Okay, I'm not going to go as in-depth as I would if I was in the classroom. All right, first of all, let me explain to you what logs are. Maybe if you guys understood what the heck it is, okay, it would make it easier to understand. You know that if I gave you a problem, let's say the square root of x, okay, and I needed to get rid of the square root. How do you get rid of a square root? You square it, right? It lifts each other away. Okay, that's because they are inverse functions. You've been learning inverse functions since you started algebra. You knew when you had to solve, oh, my pen's dying, x plus 3 equals 5. In order to get this 3 on the other side, you're going to subtract by 3, right? They're inverses, okay? Here's the problem, ladies and gentlemen. You can do this for me. You can do 5 to what power is 25? Okay, you can do that in your head. Everybody knows that x is squared. Okay, however, if I wrote 5 to what power is 32, you can't do that. This problem, okay, doesn't work out evenly. We know it's going to be greater than 2. We know it's going to be less than 3 because 5 to the third power is 125. But we don't know exactly what this is. It's going to be a decimal. It's going to be like 2 point blah, 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 whatever it is. You're not going to sit there on a calculator and try to guesstimate it, okay? That's why we have logs. Logs are the inverse of exponents, okay? Logs are the inverse of exponents. Okay, that's why we have it. You use exponents to solve log problems. You use logs to solve exponent problems. Just to give you a quick little background, okay, and I'm not teaching this to you. I just want to show you, and this is a whole section that we're skipping over because I'm not there to help you through this. This is a graph of a log function. If you remember the beginning of the year, I gave you that little booklet, and we did that little booklet with all of the graphs, and I said, don't worry, guys, we're just going to skip the log function and the exponential function because I'll teach it to you when we get to that chapter. I should have done it, hindsight. Anyway, this is a graph of an exponential. If I wanted to graph y equals 2 raised to the x power. Okay, if x is 0, anything raised to the 0 power is 1. X is 1, this is 2, 2, this is 4, 3, this is 8, and I graphed it. I left these two blank. What happens when I have 2 raised to the negative 1? Do you recall what happens when you have a negative exponent? It drops down to be a fraction. This is 1/2. When I drop this down, 2 raised to the negative 2, this becomes 1/4. Okay, remember negatives don't make the answer negative, it makes the answer a fraction. And if you can see, there's a little bit of a pattern going on here. So negative 3 would be 1/8, which means the graph, as it goes towards negative infinity, gets very close to the x-axis but doesn't cross. Okay, this is the graph of of an exponent. I'm going to take these points. This point here was 2, 3. This point here was, oh wait, that's 3, 8. I don't know what I'm writing. Maybe I need another sip of coffee. 3, 8. This is 2, 4. This is 1, 2. This point here is 0, 1. I'm just going to take those points right now. Now, if you remember, whenever we did inverses, we switched the x and y. Okay, does that sound familiar in your data bank somewhere that you had to switch your x and y? Well, if I want to find the inverse of this, I'm going to switch all those x's and y's. So instead of graphing 3, 8, I'm going to graph 8, 5, 6, 7, 8, 1, 2. 8, 3, 8, 1, 2, 3. Instead of graphing 2, 4, I'm going to do 4, 2. Instead of doing 1, 2, I'm going to do 2, 1. And I'm going to do 0, 1. Now, over here, if I look over here, I didn't mark it up, but it is -1, 1/2. I'm going to do 1/2 -1. Then I'm going to do 1/4 -2. This is the shape of the graph of the inverse. Okay, so this one right here is an exponential. And this one right here is the graph of the logarithmic. It's each other's inverses. Okay, now again, I'm skipping the whole lesson on graphing these, okay? Exponential has been in the news way too much lately with the COVID, about how the graph just goes up and how we're trying to flatten that curve, and that's what it's all dealing with. But I just want you to understand the difference between an exponential graph and a logarithmic graph, okay? All right, if you notice, the exponential basically has an asymptote on the x-axis. The logarithmic has an asymptote on the y-axis, and I just wanted to point that out, okay? I'm going to go into today's lesson. Today's lesson is not going to be to go from graphic exponential to logarithmic, but it's going to be to do it algebraically. Just actually rewriting it. It's going to be a simple lesson today, okay? I want you to be able to rewrite, and I know you guys did this before, let's start with logarithmic form. Rhythmic form. So if I give you an exponential, 5 squared equals 25. And I want you to rewrite this in log form. Just asking you to rewrite, not solve it, just rewrite it. This right here is your base. You always start with your base, okay? Now, log form, let me just give you the basic forms for exponential and for log, okay? Exponential looks like this. All right? Logarithmic, just gonna, looks like this. Okay, so we're trying to get this to look like this. You always just start with your base and draw arrows. So it's going to be the log of the base. Always remember, guys, the base goes in the bottom, almost like the basement. My arrow then goes to 25 equals 5. That's how you rewrite from base to log. Very simple. I'll show you another one to go from base to log. Let's see. 10 squared equals 100. Here's my exponential. I'm going to start with my base and write it in log form. Log base 10 of 100 equals 2. Now, this right here is something called a common log. Common log is a base of 10. You never need to write base 10. Mostly everything is assumed to be in base 10, and we're going to go more into that tomorrow when we start solving these. But you don't have to write it. So you basically, if you just wrote log 100 equals 2, they assume always base 10. Most of your calculators deal in base 10. Some of your calculators have been updated and they can do any bases, but for the most part, it's a base 10. Okay, so that's how you go from rewriting from exponential to log. You're not solving, you're not even thinking, you're just rewriting. To go from, from log to exponential. Okay, so if I have, let's say, log, let me bring this back down here so you can see. Now I'm going to give it to you like this, log 7, 1 equals 0. I have it like this, I want it like this. Again, always start with the base and draw your arrows like that. Okay, it's almost like a circle. So your base becomes your base of your exponent, that's just logical, raised to the 0 power equals 1. Think about it. Is 7 to the 0 power 1? Yes, it is, so you have it written correctly. Let's try another one. Excuse me. Log 1 over 100 equals negative 2. Wait a minute. Notice I'm missing something there. Hold on a second. Oh, I had to sneeze. Excuse me. Thank you. Okay. Notice over here, there's no base. Okay. There's no base. Well, what is the base when there's no base given? It's still 10. Here to here. That's called your common log. So your base is 10 raised to the negative 2 power is 1 over 100. Okay, so it's just rewriting from log to base, base to log. I know you might have had a teacher in the past who gave you some cute way to remember it. I know there are a few of them out there. This is all I do. I draw, okay, the arrows. So just remember how to do that. I'm going to give you some problems for homework on a sheet, okay? Remember that the common log is just when you have base 10, okay? And then there's something called the natural log. And that is when you have ln. Okay, ln has a base of e. It's the only base, so we don't write it. Okay, whenever you see ln, the base is e. That's it. There's no, oh, well, could it be something else? No, ln just means the base is e. So if I had like the ln of, I'm making this up. Let's do 5 equals let's just do 1 equals 0, okay, like that. The base is e, so the base would be e to the 0 power is 1, like that, okay. It's not written there, but that's always the base. The base is e. Okay, there's a paper attached to this in Teams. There's a document. I want you for your homework to do only numbers 1 through 14 on that sheet. Okay, I'm not doing the evaluating yet. So homework is on the sheet, the document that's attached. Do 1 through 14. Okay, hopefully I'll have your tests graded and uploaded by the end of the day. No promises though. But then again, what else am I doing? Okay, I hope everyone's staying safe. Stay inside. Okay, I know you hear on the news that it's starting to flatten. That does not mean anything. You're inside. Please, please separate yourselves. Okay, guys, love you, miss you, and I'll speak to you soon.